For thousands of years, people have looked into the night sky and occasionally seen something unusual. It was something fuzzy, sometimes bright, it had a tail, and it wasn't there before. It appeared out of nowhere and, after a few weeks or months, disappeared as mysteriously as it had appeared. When these events occurred, they were often interpreted as omens, good or bad, depending on who was doing the interpretation. But today, we have a much better understanding of what they are and how they work. Learn more about comets, how they've been observed throughout history, and what they are on this episode of Everything Everywhere Daily. This episode is sponsored by Planet Money. Tariffs, meme coins, Girl Scout cookies, what do they all have in common? Money. Economics is everywhere, and everything fueling our lives, even when we least expect it. If you're a fan of Everything Everywhere Daily and are curious to learn something new and exciting about economics every week, I recommend you listen to the Planet Money podcast from NPR. What I like about Planet Money is that I can get updates on the week's financial news in about 30 minutes. Stories like the Federal Reserve changing interest rates or the impact of trade policy. From the job market to the stock market to prices at the supermarket, Planet Money is here to help explain it all. The Planet Money hosts go to great lengths to help explain the economy. They've done things like shot a satellite into space, started a record label, made a comic book, and shorted the entire stock market. All to help you better understand the world around you. Tune in to Planet Money every week for entertaining stories and insights about how money shapes our world. Stories that can't be found anywhere else. Listen now to Planet Money from NPR. This episode is sponsored by Mint Mobile. Summer is just around the corner, and the folks at Mint Mobile have a hot take. Getting a summer bod is out, and getting your savings bod is in. This spring and summer, we want skimpy wireless bills and fat wallets. And with premium wireless plans for just $15 a month, you can have both without breaking a sweat or the bank. With Mint Mobile, I am able to use the exact same network on the exact same cell towers as I used before with my exact same phone and exact same phone number. What is different are the monthly bills, which are a lot less. All plans come with high-speed data and unlimited talk and text delivered on the nation's largest 5G network. This year, skip breaking a sweat and breaking the bank. Get your summer savings and shop premium wireless plans at mintmobile.com/EED. That's mintmobile.com/EED. Upfront payment of $45 for 3-month 5GB plan required, equivalent to $15 a month. New customer offer for first 3 months only, then full price plan options available. Taxes and fees extra. See Mint Mobile for details. Some of you listening to this episode may have seen a comet in person, but there are also probably quite a few of you who never have. Comets don't appear that often, and the ones that are clearly visible to the naked eye appear even less often. Even if you haven't seen one, you probably are at least aware of what they look like. They often have a bright head and a diffuse tail. Every comet might be a little bit different, but they all have a pretty similar appearance. When a comet does appear, however, it usually makes quite a stir, and it's done so throughout most of recorded history. Humans have been observing comets since they first appeared in the night sky. One of the oldest pieces of evidence of a human comet sighting might be found in Aboriginal rock art in northern Australia. Some Aboriginal stories and rock paintings feature sky serpents or fiery streaks, which some scholars believe could represent meteors or comets. Oral traditions sometimes describe these as omens or supernatural beings that descended from the heavens. However, due to the difficulty of dating rock art, we can't be entirely sure what event they were recording or when they recorded it. Some researchers have claimed that carvings at Gölbekli Tepe in Turkey, the oldest known structures built by humans, may encode a comet from around 10,800 BC. Again, these images are open to interpretation. The earliest known recorded observations of comets, however, were made by Chinese astronomers. The earliest confirmed observation of a comet goes back to the year 613 BC, but there may have been Chinese observations made as early as 1059 BC. In ancient China, comets were regarded with deep cultural and cosmological significance. Their unexpected appearances in the sky were seen as powerful omens that disrupted the regularity of the heavens. Chinese astronomers who operated under a highly developed system of celestial observation, tied closely to imperial governance, meticulously recorded these phenomena as part of their duty to interpret signs from the heavens. Comets in Chinese thought were often seen as broom stars, a term that reflects their sweeping brush-like tails. These appearances were interpreted through a complex system of celestial interpretation, with special attributes such as direction, color, and duration believed to correspond to earthly events. For example, a comet appearing in a particular constellation might be interpreted as a warning of an impending war, natural disaster, or the death of an emperor. Because the emperor was believed to rule by the mandate of heaven, any unusual celestial event, including comets, was thought to signify heaven's displeasure with the current regime. Babylonian texts from both 164 BC and 87 BC recorded the appearance of what we call Halley's Comet. The Babylonians called comets heavenly beards and were similarly interpreted as harbingers of doom. The Assyrians and Sumerians also recorded comet appearances on cuneiform tablets, linking them with warfare and the deaths of kings. In ancient Greece, philosophers struggled to define the nature of comets. Aristotle believed that comets were atmospheric phenomenon, vapors that ignited in the upper air. This theory would persist in the West for over 1,000 years. Even so, comets were often viewed with suspicion and dread associated with the overthrow of rulers or the fall of cities. One of the most famous historical interpretations of a comet occurred in the year 44 BC, following the assassination of Julius Caesar. A bright comet seen during the games held in Caesar's honor was interpreted by the Roman public as the dictator's soul ascending into the heavens. Octavius, later known as Augustus, Caesar's adopted heir, used this event to bolster his claim of divine favor and lineage. Coins with the comet were later minted by Augustus in the year 18 BC. In 1066, the appearance of Halley's Comet was famously depicted in the Bayeux Tapestry, which portrays the Norman invasion of England. The comet was interpreted as an omen, possibly foretelling the death of Harold II at the Battle of Hastings. This is one of the most iconic medieval depictions of a comet and shows how seriously these appearances were taken as messages from the heavens. During the Black Death in the mid-14th century, the arrival of the Great Comet of 1347 was widely blamed for the plague that would devastate Europe. Medical texts of the time claimed that the comet had poisoned the air, reflecting a blend of superstition and pre-scientific medicine. A major shift in our understanding of comets occurred during the Renaissance and the rise of observational astronomy. In 1577, Tycho Brahe observed a bright comet, and by measuring its parallax, or rather the lack thereof, proved that it was far beyond the moon. This contradicted the Aristotelian view that comets were atmospheric. This was a critical moment in establishing that comets were celestial, not terrestrial. The real scientific breakthrough came with someone whose name you might recognize, Edmund Halley. In 1705, he used Isaac Newton's laws of motion and gravity to analyze the orbits of several historical comets. Halley concluded that the comets of 1531, 1607, and 1682 were the same object returning periodically, and he predicted its return in 1758. When the comet reappeared just as predicted, it confirmed that comets followed predictable elliptical orbits and were subject to the same physical laws as planets. Halley's Comet remains the most famous periodic comet and returns every 75 to 76 years. Once the period of Halley's Comet was known, it was possible to go back and check the ancient comet observations that were made. And sure enough, many of them were of Halley's Comet. Knowing the comets were objects that orbited the sun in very long, irregular orbits was a huge step forward in our understanding of comets. However, we didn't know much else about them. For example, what were they made of, and where did they come from? The 19th century saw the advent of spectroscopy, which allowed astronomers to study the chemical composition of comet tails. Scientists discovered that comet tails were made of water vapor, carbon compounds, and dust. In 1910, Halley's Comet returned, and the Earth actually passed through its tail. Despite scientific reassurances, public panic spread fueled by tabloid reports that the comet's tail contained poisonous gas. Entrepreneurs even sold comet pills and bottled air to survive the supposed apocalypse. The world, of course, did not end, but the episode revealed the lingering power of comet superstition even in an age of science. The tail of a comet is the most notable part of a comet, and it's the reason why they're so visible. So, why do comets have tails when nothing else in space seems to? A comet is composed of a solid nucleus, which is often described as a dirty snowball, made of ice, dust, rock, and frozen gases such as carbon dioxide, methane, and ammonia. When a comet is far from the sun, well beyond the orbit of Jupiter, or even in the distant Oort cloud, it remains frozen and inert. However, as it gets closer to the sun, solar heating causes the ices to sublimate, meaning that they transition directly from a solid to a gas. This gas carries dust particles with it, creating a surrounding cloud called the coma. The coma can be tens of thousands of kilometers across, and it's what makes comets visible. Comets have tails due to the combined effect of solar radiation and solar wind acting on the material ejected from the comet as it approaches the sun. A comet's tail is not an inherent feature of a comet. It develops it as the comet moves into the inner solar system, where increasing heat and energetic particles from the sun cause dramatic changes to the comet's nucleus. Comets technically do not have a tail. They have two tails, a gas tail and a dust tail. The gas tail is composed of ionized gas, atoms or molecules that have been stripped of electrons by solar ultraviolet radiation. These charged particles are extremely sensitive to the solar wind, the continuous stream of charged particles, mostly protons and electrons, which are emitted by the sun. The solar wind can create a magnetic field, and when it interacts with the ionized gas in the coma, it exerts a force that pushes the gas away from the comet. This creates the ion tail, which always points directly away from the sun, regardless of the direction of the comet's motion. The ion tail often appears bluish and is typically narrow and straight. Simultaneously, the pressure of sunlight, specifically solar radiation pressure, acts on the small dust particles released from the nucleus. Although light has no mass, photons can carry momentum, and when they strike dust particles, they impart a small force. This causes the dust to be pushed away from the comet, forming the dust tail. Unlike the gas tail, the dust tail tends to be broader, more curved, and yellow-white in color because the particles are larger and more influenced by the comet's trajectory as they drift away more slowly. This has enormous implications for the life of a comet. Every time a comet comes into the inner solar system, it's losing mass. Eventually, a comet will disappear or break up when it loses enough mass. This is why comets appear so infrequently. If they had any shorter orbital period, let's say just a few years, it would be quickly gone. It's entirely possible that many more comets in the early solar system have all vanished. With an orbit of just 76 years, Halley's Comet is one of the shortest orbits of any comet that we know of. Halley's Comet has a nucleus of about 11 kilometers by 5 kilometers and loses an estimated 1 to 3 meters of surface material per orbit. Based on this erosion rate, astronomers estimate that it has a remaining lifespan of about 10,000 to 100,000 years, assuming that it doesn't suffer a sudden breakup. Our solar system is believed to be around 4.5 billion years old. If that's the case, how are there any comets at all? Where are these comets coming from, and why haven't they long since disappeared? According to current scientific models, comets originate in two distinct cold regions of the solar system, the Kuiper Belt and the Oort cloud, both of which I've covered in previous episodes. These areas act as vast reservoirs of primordial material left over from the early solar system's formation about 4.5 billion years ago. The Kuiper Belt is believed to be the source of short-period comets, which have orbital periods of 200 years or less. The Oort cloud is believed to be the source of long-period comets, which can have orbital periods of thousands or even millions of years, and can approach the sun from any direction. Something, perhaps larger unknown objects in the outer solar system, or perhaps even the gravity of planets such as Neptune, disturbs the orbit of these dirty ice balls and kicks them towards the inner solar system and the sun. Many of the great comets that have appeared throughout history have never been seen again. Their periods are so long that we haven't been able to record their multiple trips around the sun because human civilization hasn't been around long enough to see them more than once. So if you want to see a comet, what's your next best chance of seeing one? Many comets are unpredictable. We don't know when they will appear until some astronomer takes notice of them as they enter the inner solar system. There will be 2 comets that will be visible via binoculars in late 2025. C 2025 A6 Lemon and 210P Christensen should be visible around October and November. There are professional and amateur comet hunters who look for comets. Often, you don't have more than a year's notice of a long period comet and sometimes just a few months. Halley's Comet will be returning in the year 2061. In 2023, it reached its furthest point from the sun and started to make its way back to the inner solar system. Comets are some of the most remarkable events in the heavens, and their rarity only makes them more special. There is a good chance that a great comet, that being any clearly visible bright comet, will appear at some point during your lifetime. We don't necessarily know when, but if it does happen, make sure to go and see it because you never know if you're going to see another. The executive producer of Everything Everywhere Daily is Charles Daniel. The associate producers are Austin Oakton and Cameron Kiefer. I want to thank everyone who supports the show over on Patreon. Your support helps make this podcast possible. I'd also like to thank all the members of the Everything Everywhere community who are active on the Facebook group and the Discord server. If you'd like to join in the discussion, there are links to both in the show notes. And as always, if you leave a review or send me a boostagram, you too can have it read on the show.